Hi everyone, thanks very much for joining us today on another one of our Drone On webinar. We have a series of Drone On webinars all available on our YouTube channel. I hope today you gain something valuable from this. We are going to be talking about 100% success rate in your drone operations, and feds have some great knowledge and insights into these situations. Even in challenging conditions, because we've done it. We've been there, we've got the t-shirt, and we'd like to share some of our success stories today with you. So again, anyone who's coming in late, they'll be admitted in by my colleague Kruger, who is sharing this webinar today with me. I'm the Senior Drone Consultant at Feds. I've got 7.5 years experience in the drone industry. I'm the product sales manager at Feds, so anyone who wants to discuss the purchase and the training of drones after this event, please do get in touch with me. My contact details will be towards the end of this webinar presentation. Today we're joined by Chris Thompson as well, very close contact at senseFly. He is the regional manager for the Middle East and African areas. Chris brings years of knowledge in this industry, and anyone who has any particular questions regarding senseFly and their systems today, Chris will be in chat helping us out. So thanks very much for being a part of this webinar today, Chris.
Good morning, everyone. Thanks, Scott.
Kruger is also going to be disclosing some of our secrets into how we are successful in every single one of our drone operations. Feds have become a big presence within the MENA region due to these successful flights. And Kruger is our senior drone pilot at Feds. Today, he's going to be sharing some of his insights towards the later end of our presentation. So thanks again for being a part of this, Kruger.
Thanks so much, Scott.
Okay, just a little bit of housekeeping today. We have a chat section, and please, everyone, use that as much as you wish throughout this presentation. We will have a Q&A session, a questions and answers session at the end of the session. So please feel free to write those down. Chris and Kruger will be responding, and I will be when Kruger is disclosing his section. But we'll openly discuss this in chat towards the end. So save any big questions for that part. That would be great. Okay, so before we get started today, I just want to run a quick poll. Why everyone's in this room today? What's interested you to this webinar? I'm just going to launch that now for you. So please cast your votes. I'd like to find out the main reasons why you are with us today. Could be anything in particular. It could be you want to know more about drone mapping. You might want to know about flight planning. Maybe you know nothing about mapping and you're here to learn. So just fill in your selection. That would be fantastic. Thanks everyone for participating so far. I think we just got 4 people remaining. Great, just got a couple more. Give about 5 seconds and then I'll end the poll. Okay, just going to end that poll now. I'm just going to share some results with you all. I think the majority of you want to know more about drone mapping. Quite funny that a few know everything and they just want to see what we're doing. So quite interesting. So thanks very much for sharing that with us, guys, today. Okay, so today I'm going to discuss senseFly and Feds. We're going to talk particularly about the senseFly EBX, and then we're going to go into drone mapping, mission planning. We're going to demonstrate the eMotion software thanks to Kruger. He's going to give you a good detailed account as to how the software works. We're going to do mission planning, a live demonstration, and then again towards the end we're going to have an open questions and answers session. Okay, who are Feds? Well, Feds are the drone-powered solution provider, are the leading provider in the Middle East. We offer drones as a service, And now we're a partner with Aerodyne Group. Aerodyne Group are Malaysian-based, but they have offices throughout the world. Together makes us the largest drone company in the world for services. So we're very excited about this partnership, which took place earlier this year. Feds are the largest drone service provider in the Middle East. And thanks to the integration of hardware such as senseFly, we've become one of the mainstays in terms of drones as a service. Now, I've been part of the Feds group now for 8 months. And with my experience in products and sales and products, I'm bringing that area of expertise into the business. So not only can we provide drones as a service, now you can actually purchase a drone from us and we can provide you full training and full support through that. So we like to call buy and fly. That's our methodology behind this. And there's some great cost savings through drone acquisition. Aerodyne, as I said, were one of the largest drone service companies in the world, now even larger thanks to partnership with Feds, giving you an idea of some of the assets inspected by the company, and also the amount of countries in which Aerodyne are branched into. And of course, Feds planted straight in the center there at Dubai, with Middle East as our region. I think we are one of the shining beacons of the Aerodyne Group, I'd like to say. We offer, I would say, a turnkey solution. So if you're needing a drone for any particular project, we can offer the solution for that situation. If you need services, support, if you want to find the best possible drone for a type of survey and inspection, we have the options for you. So again, turnkey is something I'd like to just get into your minds as to what Feds can offer. We offer drone surveys and mapping, inspections, progress monitoring, and of course, again, the supply and training, that's where I come in. So if you're looking to facilitate drones as part of your operations, then Feds are your perfect partner. So who is senseFly? Well, senseFly are the leaders in fixed wing drone mapping. senseFly, I would say, are the longest established in the fixed wing industry. And because of this, they facilitated probably the very best in fixed wing drone technology. You can't really build upon the 10 years experience that senseFly have anywhere else. The comparisons out there pale in comparison to what they can offer. So through the years, we've seen an evolution of these fixed wing systems senseFly have brought to the market, and they've learned through customers such as yourself today present, troubleshooting. What do you need? What sensors are applicable for your needs? What flight times do you need? How do you want to land and launch the aircraft? They've taken all this feedback and they've created, I think, the very best in the evolution of their drones, the EBX. Very cost effective. So you find that with senseFly, their drones are cheaper than the alternatives, but offer longer flight times, greater compatibility with more sensors. They're modular. I'm going to go into a bit more detail as we progress. They're a global presence and they're a well-respected brand. They're an absolute pleasure to work with, I must say. Very competent, very easy to discuss any particular issues. And also they're very willing to learn and to help us as well. So that's why our relationship with senseFly is so important to us going forward into the next decade. Feds are the Middle East exclusive dealer, as I mentioned before, capable of service, supply. We're also partnered with Pix4D. So I have a saying in the UK, all the gear, no idea. And that means you can spend a lot of money on drones, but if you don't know how to process that information, then it becomes a very expensive paperweight. So we can facilitate not only the drones, but also the software to help you process that data and then manage it. So how is it going to save you money? How is it going to allow your building projects, your construction projects to take place? We can offer that as well. So we are the master dealer in this region for Pix4D software as well, which works hand in hand with the senseFly products we're going to discuss. And of course, we have thousands of hours of service provision in the Middle East. So no scenario is unheard of for Feds. And through this experience, we've worked with some of the biggest clients in the Middle East. Some of you present may be part of one of these companies or be directly responsible for their drone areas. But as you can see here, we facilitated drones and service and product sales for the likes of the RTA, for PwC, for CAFU, for Transco, Stephen Rock, Zane. The list goes on and on and on. We couldn't cram any more into the screen. So Feds have a omnipresence in this region, and I'm sure you've all heard of our name for many years, and you'll hear of our name many years to come as well. I like to say there are 4 stages to any successful drone flight, and today, of course, the main topic is 100% success rate, and you need to have a plan in place in order to be successful, particularly in the drone industry. So you need to plan, define your flight path. You need to understand the area in which you're going to survey. And once you've done that, you then want to pilot. So once you have your data sets, you then want to capture that data. You want to be using the drone at its most efficient point. What sensors do you need to use? What are the altitude references? What's the most appropriate flight plan? How do you want to launch and how do you want to land the aircraft? These are all areas which we need to understand. And next we have the processing. So processing the drone's georeference photos, you want to make sure they're geo-accurate. You want to make sure if they're orthomosaics or if they're 3D images. You want to ensure that the processing is just as good as the piloting itself. As again, as I mentioned before, all the gear, no idea. It's all very well using the drone to the best of its ability, but if you can't process it, then it becomes very difficult. And finally, acting. So what are you going to do with all this data? You need to create deliverables. You want to present to your team, to your management, to your client, information that they can understand. Sorry, I think there's someone just speaking in chat. We'll just make sure we meet you. Bear with me. Okay, brilliant. Great, sorry about that. So the important thing is we need to make sure that the output is as important as the input, and the workflows are compatible with the client or your operation itself. Okay, so this is quite a contentious area, but a very interesting area. And today we're presenting you the benefits of the senseFly EBX, and there are many benefits. And I really want to just put them into 2 separate sections here. You know, what are they going to benefit over your traditional multi-rotor drones, and how are they going to benefit you over traditional ground surveying techniques, which a lot in this room, I assure you, many companies out there are still using traditional ground survey methods, which take longer and are less efficient. So let's start off with comparing fixed wing drones over multi-rotor drones, particularly for mapping. The flight time for the fixed wing, particular EBX, is far longer than your equivalent multi-rotor system. Because of its larger wingspan, it's far more stable, and particularly in more harsh environments. We know in the Middle East you have gusty weather at times, thermals that can cause issues, specifically over mountainous areas. With the fixed wing solution, it provides a lot more stability because of its capability of perpetual motion. It's also allowing for safer recovery if you do lose a motor. With being a fixed wing system, you can bring that back down to ground. With a multi-rotor, you lose a motor, the aircraft is completely hopeless in terms of its recovery. Also, larger distances can be covered because of that longer flight time. So you'll find, I'll show you a slide in a second, how much more distance you can cover using a fixed wing drone for your surveying and your mapping than you would do equivalently with a multi-rotor. And this makes it far more cost effective. One flight, you can do far more of a survey than you would do with a multi-rotor. So it saves you time, and it will effectively save you a lot of money as well. It's modular. And the EBX, one of its benefits is you can take apart the drone, you can replace a damaged item on there, you can even interchange your sensors for greater functionality. And this is a real key selling point of the EBX, particularly over its competition. And I feel that this makes it a class leader in terms of cost effectiveness and capability for your surveying and mapping. And with this, you've got better control of image quality. For example, the Area X system, the payload sensor, which is 24 megapixels, is specifically designed for this drone. It's not taken from a digital camera. It has a global shutter. It is designed specifically to work with the EBX. So you're getting the very best in technology specific to your needs. And moving over to traditional ground survey. Okay, so again, we have greater efficiency. The drone can offer a much greater area of survey than your ground-based systems. You would need teams of people, you'd need many days to undertake the same area. You also have more consistent accuracy as well, because the drone is flying over one area, one point in time, and because of that, the environmental changes are less prevalent. If you have a ground team working over a long period of time, you might have more variables, and then your data sets will struggle and be less consistent through that. I like to say a picture is worth 1,000 words. So rather than just point clouds, the EBX is giving you more than just a point cloud. It's giving you great accuracy thanks to its RTK system, but it's giving you a colorful representation of the area in which you're mapping. You can take so much more data from that. And of course, again, it's cheaper. So really, it almost seems too good to be true, but it's definitely not. And this is why drones, and particularly the EBX system from senseFly, have become so integral to surveying and mapping over the last decade. They're far more cost effective than traditional offerings. You need a smaller team as well. You have a couple of operators as opposed to a team. And because of that, there's less risk. You don't need to traverse areas of interest. You let the drone do all of the flying for you. So a lot to take away from this. I could add to this, but I don't want to bore you. So this is a great representation of how the EBX, the senseFly fixed wing system, will cover far more than traditional methods and far more than your typical multi-rotor drone. So this can be achieved in 1 hour, 5 kilometers of operation, as opposed to 1.4 on a multi-rotor, and 0.16 in 1 hour with a ground-based team. So if you're still currently using ground-based GIS systems, you really need to change to drones right now. I think it's more important than ever because of the economic climate that we're in. Companies are looking to facilitate cost changes to save money. If you use drones in your operations now, you're going to make those savings straight away. And then, of course, you can represent over a longer period of time a vast cost saving over traditional methods. It's so important that people start using drones in their surveying and mapping over traditional methods. Of course, we have great accuracy as well. So ground sampling distance up to 1 centimeter, your horizontal and vertical accuracy at 2.5 to 5 centimeters. This is great for BIM. This is great for accurate representation over a larger area. Drones are very accurate in their data representation. And here it is, the EBX. So this is the drone I've been talking about, and this is what Kruger in due course will be disclosing about or how to use the drone to be 100% successful. The benefits of the drone, you have a range of sensors. So the top left there, you have the Area X. We have the SODA 3D camera, which allows 3D images. We even have a Duet T system, a thermal and RGB camera. So you can create thermal meshes. There's fantastic coverage from one drone. And again, these are interchangeable. You buy one drone. If you need multiple sensors, you can exchange them. Very simple to do as well. I recently did an unboxing on the senseFly EBX, so please tune into our YouTube channel to watch how you interchange those sensors. So the drone's going to provide high quality 3D outputs, also 2D orthomosaics if that's what you're needing. You have the option of a standard flight battery, which offers up to 60 minutes of flight time. You can even go to 90 minutes using the endurance battery system. If anyone is interested in that system, do get in touch with me after this presentation. And of course, many people can often will discuss about VTOL, they'll talk about multi-rotors and how they can land in a very small area. The EBX has a very steep landing software profile, which allows it to approach very steep and land in a very small area. So very, very relevant compared to these other products out in the market. And it's also very ruggedized. So unlike the competition, it's using carbon plastic composite. You can have hundreds of missions landing in all types of environments. The drone will keep on flying and keep on performing, as we've seen with our drone fleet. And Feds have one of the largest EBX drone fleets in the world. And we'll swear by these systems. They're just so reliable and so rugged. And they're very simple to maintain. So modular, replace a part if it fails. If you damage another item, no problem. So you can swap it very easily. And to be honest, with the competition, you'll find that you'll need to return the drone back to the manufacturer's location. It might be abroad. The benefit with working with Feds, we can do all that for you. We are quantified and qualified to replace any part on any senseFly drone, and of course we'll maintain your warranty whilst doing so. And some of the main areas in which this drone is helping clients around the world: great for mapping, great for surveying, for thermal, for agriculture. You see here there is a sensor for every sector in the market. So if you're looking to facilitate a drone to work with clients, this is your option, the senseFly EBX. If you're looking to work for a company, then one of these sensors, or maybe multiples of these sensors, will work for your operations, and they'll save you money and time. This gives you an idea of the service area in which the drone can fly. So with the endurance extension batteries, it gives you a much larger area, say over 1,200 acres at 400-foot altitude in a 90-minute flight. That's quite a huge area of operation. And of course, remember, you can land the drone, replace the battery, and fly again. So then you have multiples of these areas. So absolutely massive in terms of its operational capability. That steep landing I was discussing earlier on is a 35-degree approach angle. So compared to the left graph, so you can see two graphs here. The left graph is your more traditional landing method. The right graph gives you an idea of how much steeper the drone can land at. And it requires a third of the approach the previous EB Plus would offer in terms of its landing zone. So ideal for those more confined areas. And Kruger will go into a bit of depth in a second. Even in mountainous areas, you can land this drone and take off with ease. Thanks to the GeoBase and other ground control point solutions out there, senseFly offer great survey grade accuracy. Now, the drone we would recommend, if you're going to select the EBX, I would recommend going for the RTK or the PPK enabled system, which stands for real-time kinematic or post-process kinematic. And what does this mean? Well, this essentially gives you far more accuracy in terms of its positioning. Your ground control point or your GeoBase, as you see in front of you, will triangulate with the drone, give you far greater depth of accuracy than your traditional satellites. The drone is very strong, and as I mentioned before, using a carbon chassis, this will allow you to land the drone multiple times and just keep on flying. So it's great for very rugged terrain and environments. And as you can see here, on the left, you see the camera payload, which is the Area X housed in the drone, nice and neat. And also you see two small sensors above it. Those are LiDAR sensors. So the software on board, which Kruger will demonstrate, is very clever, very dynamic. Those two small sensors are LiDAR sensors. So essentially, when the drone is coming into land, it will constantly reference the landing area, and it will provide you information on screen should you need or to abort your landing, or should you want to continue that landing. So there's a lot of very high-end technology in these systems. The facilitation of this hardware has been thanks to 10 years of hard work through senseFly, improved winglets for better stability, more robust design, modular compared to previous systems. So again, they've taken everything the best of the previous series and they've offered it in the EBX. And finally, one of the messages I want to provide is because of its modular concept, Feds can help support you locally. So no need to return to manufacturer, no need to replace the entire drone. You only need to replace the items that are damaged. So should you have an issue, or should you need to extend the life of the aircraft if you've had many missions, these parts are easily accessible and easily replaceable. And Feds would do that on your behalf to cover your warranty. But again, a very exciting, very easy to use and intuitive platform that will offer you the very best in surveying. Okay, so at this point, what I'm going to do is I'm just going to have one more poll before I hand over to my colleague Kruger, who will take you through mission planning. So I'm going to quickly launch a poll about what drone are you currently using for your mapping project? Anyone present today, please confirm with me if you are currently using senseFly, if you're using Phantom 4. If you're not using a drone, you're using traditional methods, or if maybe you're just interested. I'll be interested to see what you all have to say today. I think so far we see the majority are not using any drones and they're still doing research, which is very interesting. I give about 10 more seconds for everyone to vote. A couple more seconds. Okay, just share those results for you. I think the majority in this room are still doing research. That's great to see. So you're in the right place. Okay, what I'm going to do now is I'm going to hand you over to my colleague Kruger, who's going to take you through the eMotion flight planning software. He's going to give you a demonstration of a certain area in the mountains and show you how we are 100% successful in our drone operation. So Kruger, please take it away.
Oh, thanks, Scott. Give me a second.
So Kruger has done thousands of flight hours. He's worked with Feds for a few years now. And yeah, Kruger, looking forward to seeing what you have to say.
Thanks so much, Scott. Good morning, everyone. So continuing on from what has already been discussed with regards to senseFly and the EBX, in terms of mission planning, the two main pieces of equipment that you're going to require is obviously the EBX and any laptop or Windows-capable tablets with the eMotion 3 software. And more specifically, the EBX uses another specific version of eMotion, which is separate to the other senseFly EBs that they have in their product line. So the conditions, okay, let me start in saying that sometimes your objective or the survey that you wish to achieve would encompass some sort of challenging conditions, whether it's mountainous terrain, cluttered terrain like, for example, a forest with an open field in the middle, and the only area that you can viably operate from is a field in between trees. How to operate the EBX from that little area safely. And then something like a golf course, for example, which again has trees, buildings, towers, maybe some radio or light towers for the golfers to use. All of them basically encompass the same methodology in terms of the approach to which you set up your flights. So I think the most viable option to use as an example will be mountains or cliff sides, which is actually part of the experience that we've gathered as Feds in the UAE. We've done quite a big number of mapping missions with the EB and EBX platforms, particularly in the north and northeastern mountain ranges of the UAE. Just as a premise to the slope mission planning, some do's and don'ts just to consider. Your equipment in this environment needs to be absolutely optimal. And that's not just the physical condition, but the software. If you will give your equipment or your EBX a personality, if it has a flu or it's a little bit ill, then it's not running optimally, then it influences your outcome and possibly your safety and the damage to the equipment. So your equipment needs to be functioning optimally. You need to be proactive of your environment that you're in. Being a mountain slope, it's obviously a grade. You don't have a flat area that you're working on, which is mostly what EVs are designed for, but they're not incapable at all when it comes to these kind of environments. But when I say you need to be proactive in this environment is you have a slope, you're on a higher altitude, which means your areas might be a little bit less than it would be at normal ground level. You have variable winds that either go upslope, downslope, or side slope, which will affect your EV's performance, but also the safety in terms of the critical phases of flight, which is launching the drone and landing the drone. So if at all possible, you would be required to clear the area of any jagged rocks, sharp rocks, any debris that has the possibility of being moved or being cleared, just to open up a little bit more space for yourself to work from. Now, bearing in mind, if you're working on the side of a mountain, you might not need such a massive area, particularly with the EVX, because thanks to the LiDAR sensor that it uses to gauge its relativity to the ground upon landing, more often than not, statistically, the EVX is spot on with its landing. So if you clear a small area for the EV to land in all likeliness, it will land in that area, depending on whether you follow the methodology that I will demonstrate to you. Check for birds, predatory birds like eagles, hawks, falcons. Reason this is an important highlight is, again, you're working in the mountains, you're working on a cliffside. This is mostly uninhabited by people, or largely. This makes it ideal playground or home for these birds, and they don't get a lot of interaction from any other birds or any people or any other environmental influences. So if you put a drone in the air that is practically as big as an eagle and it makes a very annoying noise, that is bound to attract something that you don't want to attract to your EV. From previous experience I have about 6 years experience with the EV, and in that time I have seen an eagle physically or practically shatter a drone midair. They don't play with an EV. It's fight or flight, so they go full force with the full intent of taking this thing out of the air. So if that happens, you have a shattered EV before it even hits the ground. Just something to bear in mind. There are safety features in the software that you can use to try and avoid this. If you see a predator busy chasing the EV, there are interventions that you can utilize to possibly tire them out and make them decide not to chase the drone anymore, because they are essentially lazy animals. In terms of the mountainside, you'd like to opt for a side slope landing instead of an upslope or a downslope. Reason for this is this is not just for takeoff, but particularly for landing, because if you land on a downslope, your EV will never land. It will just continue gliding down and down and down, looking for the ground. But because you're landing downslope, naturally, it's easy to see the outcome of this. You will never reach the ground. If you try to land upslope, you risk actually causing a larger impact with your drone when it actually hits the ground, because you're increasing the angle of incidence between the ground and the drone when it lands, relative to the slope, of course. You're hopefully not going to take off or land from a direct cliff face, which is obviously impractical, but a reasonable slope is still tolerable in certain conditions. And then obviously accept that some damage might be invariably probable in this kind of operation, because the ideal environment for these drones to work in is a clear open field, or wherever possible, a clear open field, which is normally flat. Now you're taking this equipment and you need to, for various amounts of reasons, possibly do this job from the side of a mountain. This doesn't necessarily mean you're going to write off your equipment. It just means that you need to take every single precaution that you can to mitigate the chance of causing damage. So in saying that, never force this kind of operation. If the cliff face is too sharp, if the rocks are too jagged, and touching on the last point on that list, if the reward does not outweigh the risk, do not do the operation, because you will likely damage the drone beyond reasonable repair in a reasonable time frame. And also, don't continue if your equipment and your environment is not reasonably nominal. I think all three of those points touch on each other quite nicely. So best practices to keep in mind for variable elevation surfaces that you're going to be flying from. In the Emotion software, I will demonstrate this shortly. Download your elevation data for the mission area. What makes this very, very, very invaluable is that not just for your data accuracy, but for your safety as well. It considers your launching and landing, which I will show you shortly, and it also considers data consistency in terms of your GSD or your sampling data that you're going to get from the drone. All your planning needs to occur above elevation data, which once again ties into the consistency of and the accuracy of your data that you're going to get. If the point that you're going to launch the drone from is the very same point that you're going to land at, then you need to set your home waypoint to above takeoff altitude. And I'll explain that shortly in a moment, why I would advise you to do that. But if the launch point differs from the landing, it's advisable to set the home point to above elevation data that you downloaded before conducting this mission. You can cross-check this with map data to just double-check the elevation setting of these points. Now, downslope launch, like I said, pardon me, that's supposed to be upslope. Upslope launch or side slope is more favorable than a downslope. My apologies for that. Reason for that is obviously downslope, your drone is just going to continue landing and landing and landing. It's never going to reach the ground. Where side slope landings is actually the optimal scenario that you want to go for, because you are theoretically simulating a flat area landing. That's the most contrary to normal thinking. Side slope landings is the closest you can get to landing your EV on a flat area, even if it's on the side of a mountain. You can cross-check this in 3D mode of the software that I will show shortly to check for elevation data voids. Now, what this is, it's something that we've been exposed to in some of our previous missions. The void basically means that when you download the elevation data of that mountain that you're working on, there's a gap, there's missing data for some reason. Now, if you're working on a mountain that is 800 meters above sea level, if there's no data on a specific point, that point registers on the software as 0 elevation data. So there's an 800-meter hole in that data. And this, depending on how you planned your mission, this can be detrimental. I will explain that a little more extensively when I get to the practical side. And like I said there in the last point, in case of a void, change your plan to above takeoff. And again, I will display the effects that this might have, or the difference that it has on the flight plan. Just from the screenshot, for example, this is with downloaded elevation data, and the flight plan is set to above elevation data. So you would set your drone to fly at a specific ground sampling distance or specific resolution, depending on the accuracy that either you require or what your client specifically requires, if it's intended for survey grade. Now, I'm sure you can imagine if you set a flight plan just above your takeoff point, the whole flight plan is going to have a constant altitude all along the side of the mountain. This then translates to your first 2 flight lines that are closest to the ground is going to give you the grade that you require. But the further away you go from the mountainside, the higher the drone flies away from the ground, which decreases your ground sampling distance and decreases your data accuracy. And it's not going to be a very consistent set of data. I could not, at the time of research, relocate the void, the 3D data void that I was looking for. But as you can see here, it might be for various amount of reasons, failed download or incomplete download of 3D data. But if you pay attention to the brown side of the data and the slightly more gray side, that would imply an elevation data void. Only the one that I was hoping to show you is a lot more severe. The mountain is not there at all. So you physically have half a mountain in the data and the other half is on sea level. Okay, so just a quick briefing before the actual quick demo. The scenario is mountainside. We're going to set the resolution for the flight at 3 centimeters per pixel. This is obviously going to vary depending on the data accuracy that you or your client requires. You can either set this lower or higher, but bear in mind on mountainside or difficult terrain, the lower you fly, the closer you're getting to the surface, and your elevation data that you have in the software is not survey grade to the actual environment. So there might be a spike in the environment or a rock face in the environment that is not completely detectable on the elevation data, which if you fly lower is going to cause your drone to institute controlled flight into terrain. And that's not something that you want, I'm sure. The overlap, the side overlap, latitude overlap of the images will be 70%, and the longitudinal overlap or the frontal overlap will be 80%. This again can vary depending on purpose. The higher the overlap, the more detail you're going to get out of the 3D model that you create afterwards. But if you're just doing the job for a consistent 2D image or orthomosaic of the area, then overlap is not that critical, but still above 50% is advisable, just so that the software Pixel can sufficiently stitch the images together. Working radius, I'm going to set to a small 1,000 meters. That's the horizontal working radius. And then height will be, I'm going to set this initially to 150 meters. And that's above the elevation data relative to the position of the drone where you started at. This I specifically set to 150 so that we can run into a problem that you will likely have at some point, so that I can show you how to resolve that. And I've chosen a random area in the UAE mountains, which is the most nicely defined mountain range that I could find at this moment. So let me just quickly switch over to the software then. This is what your Emotion software interface is going to look like when you run it for the first time or just before you plan your mission. So on the left side here, you can select the cameras that you're going to be working with, either SODO 3D, Area X, SODO Corridor. You can select multiple cameras, and then when you do your mission plan, you can actually tell it, plan this block or this area according to that camera or according to the camera that you're going to have in your drone at that time. Let's call this mountain side, create mission. Now you are literally in the middle of the mountains, as you can see here. So the area that I want to do this demonstration from is roundabout where the mouse hand is at the moment. You can go ahead and place your working area over there, and then you can set yourself there. You can nicely see the working radius. I'm going to set that to 1,000 meters. Now what this does, if at any point in the mission the drone touches or goes across this boundary, it starts a safety feature which calls the drone back to the home waypoint. For whatever reason that it might have attempted departing that area, this is a safety function to prevent the drone from flying beyond that particular radius. Now, the altitude of this area is set to 150. This means that it limits the height that your drone can fly to 150 meters. And if for whatever reason it passes beyond this point, it will force the drone down or prevent it from going any higher. I'll have to start a simulator session here. Let's just simulate, for an example, running an EBX on this area. There's your EBX. This is what it would look like if you turned your EBX on. If you placed the battery inside and you connected your battery, this is what your screen will look like. I'm not going to go into the vast amount of flight telemetry and information that you can see on the right-hand side here. It's a slightly more extensive process to go through everything that or the wealth of information that you're actually going to get from this. So in the meantime, I will quickly switch the software to 3D mode so that I can actually show you what this looks like in 3D. And I'm also, begging your pardon, going to move the drone to a more suitable area. This is just for simulation purposes. So there are some functions like moving the drone that I can do quite easily in real time in the software at the moment. So now you are, let's just get a nice view here. Now you're on the side of this mountain and you have your drone on the side of the mountain. You can see there's an up slope, there's a down slope, there is a bit of a side slope. But this is, for whatever reason, hypothetically, the only area that you can safely work from at the moment. And also hypothetically, let's suppose the area of interest for your mapping needs is where the mouse hand is at the moment. You would then go to the mission block or the mission planning side. You can choose here 3D mapping from a file, which is a KML, pardon. Or you can just choose horizontal mapping. That is the best guess to draw your mission or your area of interest in real time. From this, you can define the 4 corners of the area of interest. Begging your pardon, don't know what happened there. And also, if you have the set, let me just restart that. Begging your pardon, guys. Point. There you go. So that is your area of interest. Now, just above it, you can see your mission lines that are drawn. Those are the actual lines that your drone will fly at this point in time, depending on the settings that you modify from this point forward. Now you can change the camera to soda. I'd just like to do that. We said 3 centimeters per pixel. That's going to be your data resolution. And we said latitude overlap 70 and longitude overlap 80. You can see the changes that this has had. It has changed the flying lines or the spacing of these lines. One thing that you don't want to do in a case like this is you can see some of the lines directly intersect the mountain at this point. You would want to preferably fly directly along the mountain and not towards it or away from it, just to ensure that your drone is always clear of this area. Let me just extend this slightly for you. Also, what you'll see at the moment, every single line that the drone is going to fly on is at exactly the same altitude. So you have, from the top to the bottom, you have variable GSD or variable data resolution. So the way you would change this is change the plan above from takeoff altitude to elevation data. Now you can see a much better consistency in the variability of the side of the mountain. The drone will essentially maintain a specific altitude uniformly along the whole area of interest. This is important not just for your data accuracy, but also for the safety of your drone. Because if you have a higher point on the mountain to the one side and your flight plan is uniform all throughout, just planned above your takeoff point, then you risk running into some sort of obstacles or flying into some terrain at that point, if that's the case. Now, relative to your drone, that's the area of interest that you want to fly. That's the flight plan that it's going to do. You've verified from this relative perspective that you're not going to fly into the ground. Suppose, for example, what I mentioned earlier, if there's an elevation data void, if there's a void that for some reason on the side goes all the way back down to sea level, what the drone will do, if you just look at the plan from this perspective, from a top-down perspective, you're not going to see it. But if you look at it from a 3D perspective like this, what would essentially happen is the drone will, upon that point, it will just descend down, because it's going to try and maintain, at this point, 132 meters above that point that it's supposed to fly at. And if your elevation data in the middle of the mountains reads as 0 meters above sea level, your drone will essentially fly itself into the ground. And if you're not proactive during your flight and your mission planning, you might not see this happening, and the next thing, your drone just disconnects and you've got no idea why. Meantime, that drone is in quite a few different pieces back on the ground. So that's important in that case. Now, particularly shifting away from that to your drone over here on the side, you can see that upslope on the one side and a downslope on the other. But this is the only point that you can safely launch and land the drone from. So I'm going to go ahead and at the bottom left here, place a start and home waypoint. And if you click on this little drone point, it'll place both of these points directly onto the drone or in the drone's area. Immediately over here, you can see that little yellow line that disappears into the 3D data and comes out the other side. That means that's the point at which your drone is planning to fly. And if you continue on that point, your drone's going to intersect the ground very quickly. So what you would do in this case, seeing as you're going to, from this perspective on my screen, to the left is upslope and to the right is downslope. So you want to launch the drone downslope. What you can do then is you can physically drag this first waypoint of your drone to the right to position it in a downslope scenario. Now you can see here, if you launch the drone in that direction, it's going to climb towards that point and it's going to be, it'll be a safe takeoff. It'll clear the ground quite easily. The other reason you want to launch on a downslope instead of an upslope, even if your wind is from the back, I'm not going to go into the aerodynamics of why drones fly or how this drone flies or why wind direction is important. But if you launch the drone with the wind pushing it from the back, technically relative to the wind, that drone is not moving yet. That drone is moving backwards. So the moment you launch the drone from your hands with the wind pushing it from the back, that drone cannot fly. The wings need airflow from the front to be able to function. So at the immediate point of launch, that drone cannot fly. So it falls towards the ground until it can accelerate up to the point that it has sufficient airflow from the front to practically fly. The reason downslopes support this is if you launch the drone, it's going to start falling because it cannot fly. It's going to try and gather as much speed as it can. On a downslope, this is favorable because as the drone falls, the slope falls with it, so it never meets the ground. This gives you the best case scenario of actually launching successfully from the mountainside, even with the wind blowing from the back. So you have your start waypoint, which is this first waypoint highlighted, set away from the upslope on the downslope. So from the point when you launch, for safety reasons, you need to configure your landing before you actually launch the drone. In the event that you lose connection with your drone for whatever reason, your landing proximity is set, your landing parameters are set, and the drone can function without your intervention, and it'll land safely in most cases. Now, from this perspective, from this position, it's inadvisable to land upslope for the reason that your angle of incidence, or the angle that your drone is going to collide with the ground upon landing, is not sufficient at all. It's most likely going to be more of a crash than a landing. So in this particular scenario, what you can do, you can close the landing vector. You can limit the drone's choice on direction of landing in this way, and then you can also move it to the side. So from this perspective, let me just move it into this position. From this perspective, top down, you have upslope going to the left, you have downslope going to the right, and you have side slope going from bottom to top, or from top to bottom. It's your choice, depending on what the mountainside looks like. Going back into 3D mode, you can see, depending on where you place this, it's the closest representation that you're going to get to a flat surface landing. And it gives the drone's LiDAR sensor that it uses for landing and gauging its proximity to the ground the most time to react based on differences. Like, it basically comes down to, without elaborating, this is the most even ground that you can give the drone for landing. And obviously, depending on what the other side of this looks like, if it's also a simulation like a side slope, it accounts for undershoot and overshoot in terms of your landing. What you can also do, like I said, you can move this landing vector to the other side, but then again, in this particular scenario, you can see that it comes pretty close to the surface of the mountain at that point. So your safest bet will be this side slope. So it will be a downslope launch with a side slope landing. What you can also see here, interestingly enough, is the dim yellow line that dictates the home waypoint at this stage. It's the line that the drone will follow when it comes in for a landing. And at this point, it'll come down here on a downwind. It'll make the base turn, and it'll turn to final, going down here, descending for your landing. What can happen at this point, your turn direction, if, for example, on the left of your screen here, you change it to counterclockwise. Instead of turning to the right, you can see now it's going to turn to the left. This might not be favorable, depending on what your mountainside looks like, because this is the point that it's going to be closest to the ground, apart from the landing itself. So for safety's sake, you can change this to a clockwise rotation, and then the drone will steer mostly clear of the mountainside. It'll have as much height as possible at that point, and then it'll land perfectly safely from that point forward. I don't think I have enough time to run through the simulation or elaborate any further, other than what I've said at the moment is, particularly to mountainside mission planning, everything needs to happen above the elevation data. Like I also said, this is not an exact survey grade representation of what the terrain actually looks like. I'm sure you can imagine for yourself that the actual mountain at this point in the real world is not this smooth at all. But it is a close best guess, and it sure definitely is a lot better than planning without elevation data. So if you plan if your mission is above elevation data, it maintains clearance from the ground, but it also ensures your data accuracy and your data consistency. And in terms of landing, it will improve the safety of your launches. It'll improve the safety of your landings. If you don't pay attention to these kind of things and your landing is set on the other side, for example, let me move. If it's set over here and you're going to intersect ground, if you're not proactive and you don't see this, you are going to crash the drone. In terms of your landing, depending on where you place it, if you place your landing like this, it's going to intersect the ground before it even hits the ground. Well, that's the same thing, begging your pardon. It'll intercept the ground before it even reaches the home waypoint. If not, it's just going to continue downslope trying to land, and eventually you're going to find it 1 or 2 kilometers away from you. And I'm very sure you're not going to want to mountain climb for 1 or 2 kilometers downhill. So if you absolutely have no other choice, you would need to land it upslope, and the drone will do its best to gauge the landing as lightly as possible. But in the best case scenario for mountain slope or difficult terrain landings, use a side slope to best accommodate the flattest surface possible that you can give the drone to gauge its relativity towards the ground. From a mission planning perspective, from the safety highlights, from the do's and don'ts, this is the most practical I can take this demonstration up to this point. I'm sure there are a lot of questions for the people that don't understand this yet. If you do have questions, feel free to ask them. We can try and elaborate as much as possible within the time frame that we have. And we'll try to answer these questions as simply as possible, because there is a depth and a complexity to how you can approach the operation of this drone, and how you can make it even more safer, and the way you can understand how the drone flies, how it interacts with the environment. And that level of understanding will improve your safety even further. So I think from my side, that's about the best that I can do at the moment. Scott, do you want to jump in here again?
Yeah, thanks, Kruger. That was really interesting. I think there's a lot to take from that, specifically in how to be proactive in flying your drone safely. So I'm just going to share screen now. In terms of drone mission planning, just go through this. That's pretty much everything from Kruger's side, and I think what I want to do now is I really want to emphasize anyone who's interested in actually seeing how this works in real life. We are more than willing to provide a free product demonstration and POC. We have a dedicated flying field specifically for this drone, the EBX. So what we can do is we can take you through that mission planning in a locality in Dubai. So we can use the eMotion software, we can showcase the location we're in, how you set that flight, how you fly the drone, how you take it off, and also how you land the aircraft as well. And you'll see that in real life. So please do get in touch with me if you want to have that free POC and demonstration, if you're serious about using drones in your operations. So I think very important to mention that today. I also want to mention something that's really valuable to a lot of you who are maybe using your ground-based surveying equipment or any equipment that are no longer useful in your operations. senseFly have offered a fantastic deal. You get up to 18,000 dirham for your old survey equipment. We just need to have that in, just bring it to Feds. And what we'll do is we'll offer you that against the value of the EBX. So I think that's absolutely fantastic value there for anyone who's a GIS surveyor and is not really getting the most out of their current surveying equipment. It could even be equipment that you haven't used for years. It could be lying around. Feds are willing to help you use drones to save time, to save money, and also to improve your data flow. So a really, really fantastic deal from senseFly there. And we'd be happy to discuss this with you if you're interested in bringing EBXs to your operations. And that's pretty much it. That's our drone on webinar, how to have 100% success in your operations. I hope that was a great insight as to how we would manage one of the most challenging environments using an EBX. As you may agree, a mountainous area is very challenging no matter what drone you're flying. What I want to do now is I want to use this time for questions and answers. So what we're going to do now is we're going to have a look at some of the questions in chat, and anyone who has anything they want to ask now, I'd be more than happy to offer a answer to that. I've got Chris, who's also going to help me in chat, and Kruger as well. So let's get started with some of these questions. Okay, so first question from Hanan. I just want to ask in regards to challenging missions, what benefits do I get from a fixed wing drone over VTOL? Okay, well, I think there are, if you're going to look at a broader picture in terms of fixed wing over VTOL, I think Kruger mentioned before there, I think with multi-rotors, you're going to really struggle in certain environments, particularly in mountainous areas with the wind. So thermals, movement of air, really going to play havoc on a multi-rotor system or a VTOL system, particularly in takeoff. Kruger was talking specifically on downslopes and upslopes. With the aircraft, the EBX, the hand launch allows you to take advantage of the environments in ways VTOLs would not allow you to do so. So, for example, the EBX can be launched downwind or downslope, sorry, even with a tailwind, using the environment to benefit its takeoff, whereas a VTOL may struggle on its launch. If there is a significant wind from any direction, you may struggle to take off in the first place, and also particularly when landing that aircraft. In mountainous areas, you'll find that there are vertices, there are directional winds, which will provide very difficult VTOL landing. So that's why we use the EBX in these environments over anything else. And let's mention on top of that as well, if you do damage the aircraft, the EBX is modular, so you can repair or replace any of those items, whereas a VTOL is typically an all-in-one solution, and it's usually a total loss. So you're looking at lengthier repair times. It's more complex to repair, so it might be more expensive. So these are some things you need to take into account, not to mention the EBX is very lightweight, so sub 2 kilos. Whereas VTOLs will be over 2 kilos traditionally. There are more motors, more mechanisms, and a heavier weight allows for potential more risk when landing the aircraft. Chris, I don't know if you can add to that.
Yeah, I'd just say the wind is something you really have to take into account. For me, it's the most important differentiation between a VTOL and a linear landing fixed wing. The misconception, obviously, of wind, and wind is everywhere when it comes to operations. The misconception of a VTOL is that wind doesn't maybe play that much of a factor, or maybe that it can take as much wind as a linear landing fixed wing. The truth of the matter is, when a VTOL lands, it's obviously got crosswind when it's trying to attempt its landing, and so once you go above around 4 to 5 meters per second, which is about 15 kilometers per hour, so not that heavy in terms of wind, and those type of winds can happen anywhere, especially in mountainous regions. It becomes dangerous, and then the main selling point of a VTOL, which is it can land anywhere extremely accurately, is void. So as I said, once you go above 4 to 5 meters, you start to struggle in keeping those advantages of the VTOL. Whereas the senseFly EBX can fly and safely land with winds up to 12 meters per second, so that's about 45 kilometers, so about 3 times the threshold of a VTOL safely being able to land. And the funny thing about the EBX is the higher the wind, so the stronger the wind starts to blow, the safer the system lands. So you probably ask yourself, how on earth does it do that? Well, as Kruger showed, the system is very intuitive, and the software will choose its landing path if you've given it multiples, and will always use the wind as its main source of landing. So it will fly into the wind. So the higher the wind, the actual safer the landing of the linear fixed wing system is. So that's a really important point to note, that wind has an impact on any type of flying system, and wind can happen anywhere at any time, and especially in mountainous regions, where, as Kruger showed, that there are loads of areas that are precarious and sharp edges, and if the system isn't going to go where you want it to go, things can happen. And as Scott mentioned there as well, the VTOL systems, if they do go down, they're just one big piece, and more often than not, they're written off in those type of incidents. So wind, whatever the operation, mountainous or even on a normal field or any type of mission planning, wind's always something you should take into account when choosing a platform.
It's quite, it sounds counterintuitive, doesn't it, Chris, when you say the more wind, the better for this drone. And I think you can't say that for any other aircraft out there on the market. So really unique capability from senseFly with the EBX. So it's really good to hear that. I think going on to the next question, how much does a drone cost from Hanan? Hanan, it's variable. So there are so many options on this drone depending on your business opportunity. I would say the best thing to do would be to consult with me after this presentation. I can take you through each of the sensors. I could take you through the battery types. You'll find that comparatively, the nearest competitor is twice the cost of the EBX. So a very cost-effective drone in the fixed wing market. One of the best cost drones out there. So nothing really much to lose on this system. And I'll take you into more detail if you want to get in touch after this webinar. And moving on to the next question from Ismail. As someone who knows nothing about mapping or flying drones for mapping, where should I start? What should I learn? I think that is pretty much where we all started, Ismail. I think everyone present here today at some point knew nothing about mapping or flying drones. My strong suggestion would be, I could offer a POC or a demonstration. We could showcase that drone technology to you. We could give you helpful advice to understand how it works. I'm also free for a one-on-one video conference call after this webinar. I can showcase you scenarios, techniques. We could go into a bit more depth on your scenarios, what you're looking for, how we can train. And again, remember, even those who've never flown before, they've come to Feds in the past, they've purchased a drone. We provided a full week of intense training, both in software and practical flight training as well. So we bring you and your team up to speed and you become competent pilots. To add to that as well, Feds in the UE now can certify pilots to fly certified, which is great benefit to anyone who's looking to become a drone pilot.
I'd also just add there, Scott, quickly, anyone that does want to get additional information, there's fantastic YouTube videos on senseFly's YouTube page with our training manager, Andrea Blindenbacher, who takes you through all of the type of basics and also quite complex scenarios like Kruger's shown us today. So feel free to subscribe to that, and that is continuously updated with some pretty cool content.
Cool, pretty much. I don't know if Kruger, you want to add to anything to those questions that were asked?
Yes, sorry, the previous questions as to the advantages of a fixed wing over a multi-rotor. Chris, you touched on that very well. I just want to add from a technical or aerodynamic standpoint, you need to understand that with a multi-rotor that's hovering in the air in front of you, not doing anything, there's no wind pushing it from any side, that drone is already using 75% of its power threshold to just stay there, never mind going anywhere from that point, whether it's descending or climbing or moving forward or backwards. It's already using almost 75% of its entire power capacity. Whereas with the fixed wing, with the EB, it has a sense, almost a sense of perpetual motion once it's flying because it's gliding. So for an EB to maintain a certain speed in flight, it's maybe only using, I don't know, 25, 30, 40% of its power threshold. So it has that much more power to push and fight against the wind if it needs to. Whereas with your multi-rotor, just hovering at 75% power, now you're telling it to go somewhere with a strong wind from the front. That I don't know if that's difficult for someone to understand, but you only have that bit of power to work with in a multi-rotor, whereas your fixed wing is so much more efficient.
Yeah, that's great. Thanks, Krug. I think that's really important to validate there regarding multi-rotors and how they operate and how less efficient they are in windier conditions. I want to touch on a question that Eli's is asked, how the data will be processed. I'm not sure if you saw earlier on, but I briefly touched on software platforms. I did mention all the gear, no idea, so it's a very good question. it's all very well proposing the drone, how to take off, how to land, but how do you process that data? We are a partner with Pix4D. They are one solution provider that offer you the software to process all that data you capture. Because the EBX is using very accurate RTK referenced images, when you take all that information and you put it through the likes of Pix4D post-processing software, that will then create either a 2D ortho map or a 3D map based on your type of camera sensor. Again, we are the master dealer, and when anyone is looking to purchase this drone, that will automatically be included in the package, and that will automatically be very much a part of your training process that Feds would provide. So we would go through not just the software in the drone, not just the practical side, how to fly and how to land and how to troubleshoot and assess the aircraft whilst it's flying. We'll also go into detail as to how you can use that post-processing software to get the very best data out of it. So I hope that answers your question. Also from Eli, I think you mentioned, especially in building and infrastructure construction projects, is the fixed wing drone feasible in below ground surveys, also like tunnels? No, this is traditionally an outdoor based aircraft. And it's depending on the expanse in which you're using it. So Feds thankfully have multiple solutions depending on scenarios. So if we're looking at below ground surveys, we have a solution for that. It won't be the senseFly EBX. However, for building and infrastructure construction projects, very much so. In fact, if you want to have a one-on-one video call with me, I've got some great EBX examples showcasing how you can time-lapse a project, how you can do a regular survey of that area and you can see the changes using the camera sensors. You can also even measure the areas of construction. So that's a really interesting subject. There's so much we can talk about, and we're running out of time. But if you're interested, please get in touch with me after this event. I might get in touch with you and showcase that to you. And can you transfer the data once the drone is in the air? No, it's stored on board the aircraft on an SD card. And once the drone lands, sorry, it's stored on board the camera. Once the drone lands, you will then plug that into your computer and you will transfer that data. So it's all done on board the aircraft. It's the fastest and easiest way to process that data. And I think that's pretty much all. We've got some more questions from Hanan. How does the EBX compare in comparison to, or how does it compare to the competition? Okay, so quite a few things I mentioned before. I don't know if Chris wants to help me on this, but I do know that pricing is a key indicator on the system. I know in these current times that people are watching their purse strings. Let me emphasize though, drones and particularly EBX, the intended use is to save money. Remember, you're covering far larger areas, far faster, using fewer people, and with more accuracy than your traditional methods, even using multi-rotors. So it would traditionally take a team weeks to encompass a large area where a drone will take 1 day. Already, it's a cost-saving system if you're looking at it that way. It's also cheaper than the alternatives in the market, so it's cheaper than the competition. There are some VTOL systems out there, even multi-rotor platforms, which are far more expensive, and they are not modular. So you're paying for a more cost-effective modular system on the market. It has one of the most diverse payload ranges as well. Chris, do you want to tell us all about some of those payloads?
Yeah, for sure, Scott. And as Scott has shown in the presentation earlier, he listed the payloads which we offer, which are really specific for certain types of mapping. So anyone looking to invest in a system is predominantly looking to invest to save money, but also to potentially increase their portfolio in the types of projects they can do in-house, or obviously to sell on as a service provider. So the complexities and the differences in the payloads we offer really do offer all of our clients a really broad scope in the work in which they can do. So I think it's really important when you do choose a system that the payloads, obviously, it's the image that you're paying for. The system needs to be stable, needs to fly well, and that's certainly what we have. But the payload capacity and the images is what is going to generate those the revenues for people investing in our system. So I think the diverse payloads that we offer is certainly one of the key aspects, and something that no one else on the market has, specifically the SOTA 3D, which again, Scott can give more info, but in a nutshell, it's basically giving you the advantages of a quad with oblique imagery as well as nadir, but then the fixed wing's giving you the large scale mapping. And then the Duet T as well, which is a dual sensor, which is RGB and a thermal camera, which allows for 2 images taken at the same time. So for accurately georeferenced thermal data, which again is pretty revolutionary on the market. And one of the biggest things I'd say, again, going back to VTOL and linear fixed wing, is the weight of the system. We mentioned with most VTOLs on the market, you're looking at well over 2 kilos, usually with full payload at least 4 to 5 kilos. So weight is important for several things. Obviously, safety is one, safety for the user, safety for the environment, and of course, if the system does go down, it's safety to that investment that the clients have made. But safety, especially, and me being based in Europe and with the European regulations, which will affect every single country in the European Union as of next year, and then might be replicated around the world. We do see often that the North American and European standards get replicated across the world. That sub 2 kilo is going to be extremely more beneficial when it comes to flight operations, when it comes to where you're able to fly and what you can do. And anything over 2 kilos, you're going to be very much limited in what you can do. So the big question there is anyone looking to invest is not only what's currently on the market, but also how the market may change and how especially the regulations may change. And so anything over 2 kilos, you might find yourself in a year or two not able to use it anywhere near as much as a sub 2 kilo system. So those are definitely things to take into account before obviously investing in a system. And obviously myself or Scott are always available to go into more detail as to these advantages over the competition, but also any other questions anyone may have.
That's perfect. Thanks so much, Chris. I think the next question could be something that Kruger would like to answer from Ismail. I recently started learning geographic information system. Would that help with drone career?
Well, although I didn't do GIS myself so far, a lot of the important work in terms of the data that you process and manage after your flight, that has to do with GIS, and that becomes crucial then as a crucial skill towards creating something like a turnkey solution. So you're not just a pilot, you're not just flying the drone, you're not just collecting the data, you're processing it as well, and you're able to get information out of that that's actually valuable.
Yeah, I
so
think that's
to answer the question, GIS is very important.
Yeah, great. Thanks, Kruger. Yeah, so Ismail, I hope you agree that it is it's a great, I'd say, subsidiary in your learning with drones. I think it's gives you a bigger picture, so definitely important. And one from Rex: when we plan the mission with varying altitude, will it affect the camera's direction during its climbs to the next altitude, or has it a single axis gimbal? Kruger, if you want to answer this one, that would be great.
Yeah, sure. I was waiting for this one. So what the drone does with the standard camera is not gimbaled at all. So it's fixed relative to the orientation of the drone itself. What the drone does, however, it doesn't take photos during climbing or descending or turning. This is accounted for in the flight plan. So it would orientate itself outside the area of interest before it flies a straight line across the area of interest, during which it will take photos. During this time also, when it's taking pictures, it stabilizes itself in flight before taking every single picture. So in that sense, your pictures are stabilized as much as possible. But I'm sure you can imagine if you're flying in windy conditions, this might affect the picture quality slightly, but from my experience and from what I've seen, the camera in the EBX, the SODA camera, is fairly advanced. It accounts for most of these situations. But there's another payload that you can also get for the EBX, the SODA 3D. And Chris, correct me if I'm wrong, but this is one axis gimbaled from side to side. Correct. So while your drone is flying, the gimbal the camera is pointing down at all times. It doesn't matter if the drone is turning to is turn to the left slightly or turn to the right slightly. And that accounts for your drone stability in flight, and also accounts for the stability of the camera when it takes a picture. So that offers a lot more versatility, but that's only with the Soda 3D camera payload. Chris, do you want to touch on that?
I think you've covered it quite well, Kruger, so nothing to add there.
Yeah, thanks, Kruger. That's really important. So yeah, it's dynamic depending on the situation, depending on your payload as well, and depending what you need. It will give you that information at hand. Niver, thanks for the question. Compared to the competition, what environments can the EBX fly in? Well, I think actions speak louder than words. I think Chris might correct me if I'm wrong, but I think there are over 5,000 users operating this system, and that's all over the world. So from the harsh desert of Dubai all the way through to, I'd say, the mountain peaks of the Himalayas. I know there are clients using them there. So very harsh terrain, harsh environments being used all over the world in all different types of scenarios.
Yeah, I'd just mention that. I mean, I've been at senseFly almost 7 years now, and I've seen firsthand as well the systems, as Scott said, being used in extremely hot, extremely cold, extremely normal, aka Switzerland scenarios. But it very much is a system designed to be able to operate in most areas, high altitudes. And again, the ruggedized design of the system allows you to really put it to its limits. And users are doing that. We see people that have got thousands of flights on the EBX already, and so we're using this weekly, sometimes daily, to do whatever type of operations, especially for argument's sake in the mining industry, where they require daily or weekly information on stockpiles. The system's being used very frequently, and obviously weather isn't really much playing an impact. And if there are parts that need to be replaced, as Scott's mentioned, we have our service centers all around the world which are ready to take action to keep our clients operational.
That's great. Thanks, Chris. I think we're all done for questions. I hope you've enjoyed it. We will be doing more webinars in the future. We always will. Drone On is a series of webinars. So please stay tuned. Subscribe to Feds through social media. Keep an eye on our, or subscribe to our YouTube channel as well. Also do get in touch with me if you have any more questions. Just to share my details again, they're on the screen. You can call me, that's my mobile number. I'm also available on WhatsApp on that number. Some of you may already know of me. And also my email address is on screen. Nice and easy to remember, scott@feds.ae. Again, thank you very much for tuning in today. We hope to see you in a future Drone On webinar. Let's see if anyone would like to take advantage of that fantastic senseFly offer as well. If anyone's using your ground-based GIS systems, please do get in touch. Anyway, thanks again. Thanks for Chris for being involved from senseFly. Thanks, Kruger,